Section 7.3.1 IP Addresses and Subnet Masks, Part 3. These two analogies should help you better understand why we are learning to segment a network with subnets. Both ships and cars use compartments or segments to limit how far a threat can move and limit the impact on passenger safety. With ships, shipbuilders are now required to construct ships with compartments so that if water breaches into one compartment, it is blocked from spreading into other compartments. This helps the ship maintain buoyancy. With cars, Henry Ford added firewalls in the first automobiles to prevent fires or other malfunctions in the engine compartment from affecting the safety of those in the passenger compartment. Segmentation is a widely accepted and effective security strategy that has been implemented throughout almost all aspects of society. There are two different formats used to provide a subnet mask, and we need to be able to recognize both. Because it becomes irritating to write 255 so many times, a shortcut called / notation was created. Just count how many bits you are going to use for the subnet mask, counting left to right. If we have one 255 in our subnet, that means we have 8 binary ones, and the / notation is /8. If we have two 255s in our subnet, there are 16 binary ones, and the / notation is /16. If we have 3 255s in our subnet, there are 24 binary ones, and the / notation is /24. These formats will be used interchangeably and appear often in the upcoming lessons and labs. Here we have an IP address that is 129, which means it has 3 255s because it is in the last grouping. We know that there are 24 binary ones in the subnet, so we would say 192.168.50.0/24. To go from / format notation to dotted decimal notation, you simply convert the bits in each octet to their decimal number. This circles back to binary or decimal math. Now we're going to talk about reserved addresses in networking. These are not related to subnetting, but they are outliers and will be used in upcoming labs. We use the loopback address to test devices by pinging 127.0.0.1. This means we send a test message to that address, and it is as if I poked myself. If my response is ouch, then we know that I'm in working order. If I don't respond to the poke, then there's something wrong. Same is true of the NIC. If I ping loopback and get no response, then either the NIC is physically defective or it has a corrupted configuration. Something to be aware of because a failed loopback test would mean the NIC needs to be replaced. Here's something fun for you to look for. There are actually doormats that say there is no place like 127.0.0.1 because there is no place like home. In every network, there are host addresses that are reserved and cannot be assigned to devices on a network. Remember that computers use 0 as the very first digit in counting. So the first address in an IP network is 0 and cannot be used for any device. It is used as the entrance to the network. Think of it as the main post office in your town. While IP numbers assigned to devices are like home addresses. If you try to assign the IP address to a computer, it will generate an error message in the same way that you don't live at the post office. The reverse is also true, that the host bit positions with all ones or 255s cannot be assigned to a device. That is the last address for any network and is used for broadcast. Think of it as yelling to everyone in the network. To send the same message to every device in the network, you would have to address it to every single device by specific address, or you can use the broadcast address instead.